Okay, so any question, anything you'd like to start with? Anyone? Anything?
I had trouble with 22 on the homework, which I know is something we've like gone over, but
Yes, so which section 22? I did not write solutions yet. So when you say 22, where am I looking at?
on the homework, like
Yeah, so,
homework
yeah, which
questions.
section? Which section of the homework? Yes.
Oh, I would have to pull it up. 1 second.
Do you have the problem?
I just remembered to ask about it, but I would be able to pull it up for you.
You don't remember which section? 3, 4, 5?
I'm not super sure.
If you need more time to find it, you can let me know when you find it. Is that okay?
Yeah, that's fine.
Okay, when you find it, I'll stop. Is anyone else interested in working on anything, or can I move on? Okay, so we're continuing now with 1.6. Two rules are very important: product and quotient. There are two different rules. So the product rule is the following. A function multiplied by another function prime. You cannot say f prime g prime. Please don't do that. This is a specific rule, which is the product rule. It's a product rule. It's applicable here because there is a product of two functions. So f prime g plus f g prime. You can twist them if you want. If you find them written differently, the rule written differently in a book, I'm fine with that. I prefer 1 times 2 prime, but this is my habit. You create your own habit, and I'm fine with it. 1 prime times 2 plus 1 times 2 prime. I think you will never make a mistake if you remember that. You can say 2 prime times 1. It's up to you. I don't dispute that. So I'd like us to apply the rule on problems. And let's choose. So we are on page 162. And let's apply the rule on any problem from 1 to 12. Let's illustrate the rule on any problem from 1 to 12.
Can you do 12?
Okay, let's do 12. I think we should start with something more human, like, for example, 5. And then we can look at 12. So in 5, we have a function g of x. So this is on page 162. And this is 4x squared and multiplied by x cubed plus 5x. So this is problem 5, g of x, 4x squared, x cubed plus 5x. Okay, so you can say, I don't need to use the product rule. What are you talking about? I will just distribute and then differentiate. Correct. This should be the best way. But we want to apply the product rule in this situation, where this is function 1 and this is function 2. So the derivative of this function will be the first function prime. Can anyone give us 4x squared prime?
AX.
Very good. Times the second function, I have to copy it. Plus, I copy the first function now, and I multiply it by this function prime. Can anyone give us x cubed plus 5x prime?
3x squared plus 5.
Very good. And now you can say, you're going to say to distribute. Yes, I'm going to say distribute. So why didn't you distribute from the beginning? Again, we wanted to illustrate the product rule. So I will continue. 8x times x to the third is 8x to the fourth plus 40. x squared plus 12x to the fourth plus 20x squared. And yes, I will rearrange them in combine like terms, rearrange the function in descending order. So 20x to the fourth and plus 60x squared. So these are the steps that we have to follow. Now the floor is open. If you want to choose 12, we can still choose 12. Is that what you want? I don't.
That's good.
Okay, so for problem 12, this is g of t equals 2t plus 3 the square root of t plus 5 and multiplied by the square root of t plus 4. Yes, of course, I would not apply the product rule on this function. I would distribute and then differentiate. But we want to illustrate with a product rule. So g prime of t equals, when we differentiate this, 2t prime is 2 plus 3. When I differentiate this, remember the shortcut. Do not change the square root of t into t to 1/2. It's not a mistake, but it's.
Can you switch back to your
Oh, sorry, thank you, sorry. Okay, so let's do this again. So 2t prime is 2. So I copy 3, and when I differentiate this, I use the shortcut. Do not change the square root of t to 1/2. We already have the shortcut. 5 prime is 0. I have to multiply by the square root of t plus 4, and then plus. I have to copy the first function, which is 2t plus 3 the square root of t plus 5. And I have to differentiate the second function. And I will keep it as is. I will not continue because it will take a long time to distribute and combine like terms. This is good enough for now. So this is 1 over 2 the square root of t. Most probably a lot of simplification will ensue, but I'm fine with just this step. Okay. I'd like to move on to the quotient rule. Any questions on these problems? Sorry. Any questions? Any questions? Okay, so the quotient rule is very similar to the product rule, and I'll explain why I say that. So when you have a function divided by another function, the denominator of this fraction is simply g squared, nothing else. But the numerator is the product rule, but with minus. So easy to remember, the denominator is simply squared, and the numerator is the same thing, but with minus. So I have f prime g, but minus fg prime. So let's illustrate the rule with a quotient. So allow me to choose the first one, and then you'll choose the next one. It says differentiate each function. So I'm going to choose 23. Then you choose the next. So we have y equals, which is the same thing with f of x, equals 5x squared minus 1 over 2x cubed plus 3. If you remember, it doesn't matter how you write it. You can write it dy over dx. You can write it f prime of x. You can write d of f of x over d of dx. There are so many different ways. Choose the one you like. This is an important notation. We're going to use it again. This is very important. This is same thing. So because it's a quotient of two functions, I start by squaring the denominator, and the numerator is a difference. The numerator prime, which is 10x, times the denominator, 2x cubed plus 3, minus the numerator, 5x squared minus 1, times the denominator prime, which is 6x squared. We cannot leave this alone. I left this one alone because it required some time. We can go back and simplify it later. So I don't want to waste time on algebra. But in this case, we have to. We have to simplify this function. And we can go back, as I said. If we have time at the end, we'll go back and simplify that. So I distribute 20x to the fourth plus 30x minus 30x to the fourth and plus 6x squared. So again, 10x times this is this, 10x times 3 is this, 6x squared times this with minus in front is this, 6x squared times negative 1 is positive 6x squared. So 2x cubed plus 3, everything squared. I have to combine like terms and present everything in descending order. Let's stop for a moment. Any questions? Are you okay with these steps?
Just a quick question.
Yes, please.
How did you get 30x to the 4 on the? Okay. Oh, okay.
And then this
Okay, I
product.
see. Thank you.
My pleasure. Other questions, anybody? So here we have negative 10x to the fourth, and then plus 6x squared plus 30x divided by 2x cubed plus 3, everything squared. Under normal circumstances, I will factor out the negative 2x, but this is good, in the numerator, but this is good enough. Do we understand how the quotient rule works? Would you like to pick another problem?
Can we do just one more, please?
Yes, of course. So will you be willing to choose all these quotients?
Can we do 45?
Yes. Let's do 45. Where is 45? I see it. So 45 on page 163, and that is f of x equals 3x squared plus 2x, everything divided by x squared plus 1. Perfect. Okay. So when we apply the quotient rule, we know that we have to square the denominator. You don't differentiate it, you don't touch it, you just write this, and you will never expand it. This is it with the denominator. The numerator prime. Can anyone give us the numerator prime times x squared plus 1 and minus 3x squared plus 2x times the denominator prime? Can anyone differentiate the numerator and tell us what to write?
6x plus 2.
Very good. Thank you so much. And the derivative of the denominator.
2x.
Thank you. Thank you so much. Perfect. I have to distribute. Now here you remember this is FOIL because I have two binomials. It doesn't matter if you start from here or you start from here. It doesn't matter. X squared times 6x squared. X squared times 2. 1 times 6x squared. 1 times 2. 2x distributed to both with minus in front. Minus 6x cubed and minus 4x squared. Okay, combine like terms. 6x to the fourth is the first one. 2x squared plus, oh, I'm sorry, there is a 6, negative 6x to the third. 2x squared plus 6x squared. 8 minus 4 is 4, and plus 2. X squared plus 1 squared. We never expand the denominator. It has to stay as is.